Hey guys, welcome back to my channel. This is Paula Paz with Automated Dynamics and I'm a field applications engineer. And for today's video, I want to show you how to do alternative Modbus register mapping in the DXM configuration software. I want to show you how to do control logic, math logic, and how to set alarms with threshold rules. And recently I had an application where I used all of these rules, and I just thought it'd be the perfect opportunity to make this video and show you how I solved this problem and how I went about building my program, because I believe that I was pretty efficient with the amount of rules that I created. So I hope this helps you. I'm putting chapters down here below, so just scroll to the topic that you need to look at and then give me a like if you can remember to just give me a like, and we'll get into the video now. Okay, so the application is for leak detection, wireless monitoring of any leaks in a particular tank area. So we have a total of 6 tanks, and we've got 2 capacitive sensors that are strategically located underneath the tanks to detect any kind of liquid on the ground. Turk was super awesome. They created a very special mounting bracket that allows us to mount these sensors flush to the ground, and so that's going to be a really great add-on to this application for them. Anyway, I digress. And the sensors are going into a DX80 performance node, and they're actually being tied into discrete input 1. And we are supplying battery power voltage to those sensors, and we're supplying what I think 12 volts, and it wakes it up at every 5 minutes. So we have a sample rate of 5 minutes and a report rate of 5 minutes as well. So that suffices the requirements for this application, and they're all reporting back to a main enclosure where I have just a power supply, an industrial Ethernet cable going out to their SCADA system, and we have a tower light that's tied to discrete output 1 and discrete output 2. And that's just the red light's going to tell us that if there's any type of error, whether it be on the tank or whether it be a node dropping out, maybe because battery problems. And then you have a green light telling you that everything's good, we have no alarms. And then we are using an Omni high gain antenna that is going to allow us to break through wirelessly to some walls, so that we can get access to the other side where some of the other tanks are located. So we did do a site survey. Everything looked great when we used this Omni antenna, and so this is pretty much it. So I have a total of 6 nodes, 12 sensors, 1 gateway. So that's the application, and so let's get started with the programming. Alright, so first things first, guys, is always going to be, let's do the register mapping. So what I wanted to point out in this case, because I'm going to be tied into discrete input 1 of all of my nodes, I really wish there was a way of quickly doing that instead of the traditional method where you use the mapping and then you have to do like pretty much just like one individual rule at a time for each discrete input. So I wanted to turn your attention to our alternative Modbus register organization within the DXM. You can find this in the instruction manual under section 3.41. And in here, you've got a better way of doing some of these things. So for example, if I scroll here down to, well, actually, let me just point out this discrete bit packed registers. If you're looking to save, maybe instead of using an entire 16-bit register and you just want a single bit, we can do that in these discrete bit packed registers, so you can just run maybe your PLC a little bit more efficiently when you're doing or setting up function blocks, things like that, where you want to execute a limited amount of holding registers at a time to read your Modbus registers on the radio. So anyway, that's here. You can look at that, and then if you scroll here down, you'll notice our analog input and output registers. So check this out. So I'm really interested in input 1 for nodes 1 through 6. And so if I use this alternative Modbus register address, I can quickly do just a single rule instead of having to do 6 entirely other rules. So let's do that now. So I'm actually going to do that for node 1, I'm sorry, input 1, and then also for my status register. So if you know, input 8 is reserved as a status register. If I have a value of 128 on there, I should it means I have good communication. If I have anything other than 128 value on this status register, it means that my node is either not present, it's not connected, or the battery died, or I have an error on my radio. So these are the two registers that I really am interested for my register mapping. So let's get started with the register mapping. So I'm going to add my two read rules now. So this one's going to be input 1, nodes 1 through 6. Slave ID 1 because we're dealing with performance, and we know we're going to read 6 registers at a time. And if we refer back, it was register 6802. It automatically gives me 6807 here, so it just goes through all the way. And I'm just going to keep these at 1 through 6. If I wanted to do input 2, for example, of nodes 1 through 6, then I would do here, it would start, I believe, at 6952, and that's where those are going to be located. If I go back here to my instruction manual, starts at 6952. Okay, so this is the alternative register mapping that you can use. Quickly do node status 1 through 6, and those start, I believe, at 7852. And I'm gonna, oops, I forgot to allocate the registers here, so I'm gonna do these 7 through 12, and then I'm gonna do 13 through 6 here. So that should be good here. So notice I don't have them up here named because I haven't named them yet. So on my local registers, another quick trick is to modify multiple registers as you create your program. So we said registers 1 through 6 were going to be discrete input 1 for node underscore, and I'm going to check this box, increment starting at 1, modify registers, and boom, it just writes all of those for me in a single stroke. So then 7, I believe it was 7 through 12, that was going to be DI2, and I'm doing DI2 just in case I decide to in the future use that. And then for my node status registers, I'm going to do nodes 1 through 13 through 18, and that's going to be node status for status node. This is grammatically better, and it does it for me. So this concludes part 1 for the alternative register mapping. I hope that made sense to you, and you know, you save a lot of time by just doing it this way. So I just wanted to bring some attention to doing it this way. Okay, so we have our register mapping here. We see that everything got populated here. If we check our work, make sure everything is good. That looks good. I actually did forget to do the right rule. We do have that tower light segment. We have 2 segments on there. So we're going to write 2 local registers starting at 73. That's just a random number that I'm picking because that worked for me later, and I'll go over that. But when you're dealing with the DXM outputs, you've got a different board that you're working with there, and the address for that board is number 203. If you don't know where this number is coming from, a quick trip to our tools section can help you figure that out. So DXM outputs here under register source, it gives me the address for all of that. If you don't know where that stuff is, ISM registers 1, you know, DXM display registers are 201, and DXM outputs are 203. So that's really helpful when you're working kind of on working without the manual or something. 2101 is the starting Modbus register for those outputs on my DXM. So I've got that done now. Okay guys, so we are ready to get started with our action rules. Okay, so the first rule that I'm going to start with is our control logic, and I'm going to basically group the two sensors that I have in that discrete input. I'm going to tie those two into an OR gate, and I'm going to call that our alarm tank 1 flag. So this is what we're going to do. This is where it comes useful. So tank 1, and we do have a lot of options here. I want to know if either of these two, okay, oops, no, 7. I want to know if discrete input 1 or discrete input 2, if either of these two are enabled, I want to know about that. So I'm actually going to put the result in register 40. That's an arbitrary number. I just picked that. I'm going to go and name that right now in a little bit. And so this right here is now something that I can use to create a threshold to let me know if alarm tank 1 goes off, then I need to set up an alarm for this. This is just the OR output result. That's very important. Okay, so I'm gonna do the rest of these now. Okay, so I've now finished writing all of these, so I'm going to go into my local registers and modify these really quick so that I know what's going on. 41 through, what was it, 45. And this is my OR alarm tank underscore, and that's going to quickly give me what I'm looking for here. Under action rules, you'll notice that these are now named so I know what's going on. Okay, so now that I've created my OR gates, I'm ready to do some threshold rules. So for example here, this is going to be my tank 1 alarm. So if either of those two sensors go off, I want to create an alarm. So we just used that OR gate to bring those two together. If those are equal to a value of 1, if my OR gate goes off, when this is true, I want to set my local register, and I'm just going to pick a number 50, for example, and I'm going to set that one to a value of 1, and this is going to be my alarm, okay? This is my official alarm, number 50. When that's true, I want my value, when it's not true, I want my value to go back to 0. Okay, so this is what is now going to create that alarm. So now I got to go back into my local registers, and number 50, this is going to be my alarm tank 1, for example. But what I'm actually going to do here is I already know what I'm going to do multiple of these. It's going to go, I believe, up to 55, and this is going to be alarm tank underscore. And I will quickly create those here now. So that's done. And now I just got to build the rest of these alarms. Okay, so I've now created all of my tank alarms, so I know exactly which one is going off. So this is something that I wanted. This is ready to go. I'm now ready to create a new alarm, and so I'm actually going to use the math logic for this. And so I'm going to add a math rule, and I'm going to OR all of my tank alarms together. So if I have any tank alarm, you know, I can put all of those together. So I want to show that off here. A logical OR is what I'm going to be using for that. So I'm going to call this my OR tank alarm. And I'm going to set, we did local register 40. And then the difference here is we're going to do a through. And this is going to allow me to now group all my tank alarms because we put them all together 40 through 45 continuously. We can do stuff like this. So I have all of them here. So if any of those go off, I'm going to have a value here of, I'm going to pick 70 for this because that's what I ended up using. So I'm going to keep it actually 71. I'm going to keep it the same as my original program. And so now I'm going to go back into my local registers. I'm trying to get into the habit of just naming everything as you go along so you don't forget what you've done or use stuff on top of each other. So I'm just going to call this my ore tank status. Okay, so if I already created an alarm for every tank, why do I care about this tank status? Well, it does come in handy for me in this project because what I ended up doing is that I did threshold rules for all of my node status alarms, and I think there's probably faster ways of also doing this. I'm not claiming that this is the most efficient way, but this is how I did it, and I use the control logic and math to also add to my node status. So let's combine our node status alarms and our tank alarms. So I've gotten all my tank stuff done here. I've done all the tank. Now I want to do my node status. And then I want to end up with combining those two to create my any error alarm. So let's do our node status real quick. Our node 1 radio status threshold rule. So let's do that. And for this one, we use starting on number 13, status node 1. If that's not equal to a value of 128, we want to know about it. We want to know about it in, let's put this in local register 56. Again, this is a arbitrary value that I picked that suited my memory map, and you can do that as it works for you. So remember, this is set to 0. So now instead of, seeing 128, I'm going to have an on and off bit to see if the node status is good or not. So value of 128 tells me that I have good communication. If I see 0 or anything else, I'm going to know that there's something wrong with that node. Okay, so I'm going to do this now for all of my nodes. Okay, so now I'm done writing all of my node radio status alarms. So you'll notice that I still have not given names to local registers 56 through 61, so I'm going to quickly do that right now. So we're going to start here with 56 and end with 61, and we're going to call these just status alarm node underscore, starting at 1. Boom. That's done all the way to 61. Okay, so that's written now. That got updated here. 1, 2, 3, 4, 5, 6. Checked all my numbers. Okay, that looks right. So now I have all of these, and I want to probably do the same thing over here in my math logic. I want to pretty much just clone what I did earlier. I'm going to call this my OR status alarms, the logical OR, and we're going to start on, we said 56 through 61. That's going to OR all of these together. So if any of these do not equal or are not equal to 128, I'm going to put that value in local register 70, because that's where I'm putting my alarms, in the 70s. So we go back here now, just update that as my OR node status. Okay, so that's great. I've got all of those OR, and now what I want to do is I want to AND these two together because I want to create an any error alarm. So in my control logic, I'm going to add a control rule, and I'm going to call this my any error alarm. And this is also going to be an OR, and I'm going to put together the two alarms that I just created, which was my OR gates, which is 70 and 71, and I'm going to dump this into a new register, 73. Okay, 73, let's go back in here into our local registers, get in the habit of giving it a name, and this is my any error alarm. Okay, so now that I've given this a name, this is done. All I have to do is make sure I write this into my output. So 73 is my, basically this is my red segment light, which is why I had us use number 73 over here in our write rule. So this is directly writing local register 73 into Modbus register 2101, which is our universal 1 output. So this is how, maybe I could have flowed this instead of doing it in the beginning. I could have put this around the end, but that is how I do my any error alarm. And so that begs the question, how do you do your all clear alarm? So very simple. In my control logic, let's add a control rule, and this is going to be my green light, so we'll call this my all clear light or alarm to keep things the same, and I'm going to use a not. So basically, if number 73 here, any error alarm, if that's not on, then I'm good, and I'm going to put that into 74. And local register 74 is our other write rule that we haven't named. You see we have it there, but we didn't name it, so now that's a little confusing. So again, get into the habit. So this is going to be my all clear light. And I'm going to take the OR off of this because that doesn't go there. This is my any error alarm. Okay, if I wanted to create alarms for these tank statuses and node statuses, if I wanted to create individual any tank alarm, for example, or any node alarm, I would need to throw this value back into a threshold rule and say, for example, I don't know that this is very necessary. I did it at first. I don't think it's necessary anymore in retrospect, but for example, just for the sake of going through this, any radio status alarm, I'm going to allocate that OR gate that I just created for my any node status. If that's equal to a value of 1, then when that's true, I want to set local register. Let's create a new one, number 75, to a value of 1. And when that's not, when that's not on, we're going to set that to a value of 0. Same thing with our tank. Any tank status alarm. Any tank status alarm. We're going to say number 71, which was our OR. If that's equal to 1, then set local register 76. We're going to create that one into a value of 1. When local register is not on, then turn it back to 0. So, okay. So this will officially give us an alarm for those OR gates also that we created. Let me just go back here into our local registers and give these. So there you have it, you guys. This is how I do the alarms and what I did for this project. It turned out to all work, so I tested it and it all does work well and pretty cool. So I hope this was helpful to you, and if it was, be sure and give me a like, you guys. See you on the next video.